Hey everyone, ready for another deep dive.
Always.
So this time we're looking at like seriously cool discovery. This article from SciTechDaily.com, it's called,
Stunning James Webb images reveal the birth of a Milky Way twin.
yeah, that's it. And get this, it was published just yesterday, Christmas Day. What a present, huh? Talking about a gift for space enthusiasts.
It's certainly a remarkable finding.
So this galaxy, it's got this catchy name, Firefly Sparkle. Okay, so silly question maybe, but is it just the name that has everyone buzzing?
Well, the name is charming, that's for sure. But the images captured by the James Webb Space Telescope, they're just breathtaking. But it's not just about looks, right? What makes Firefly Sparkle truly fascinating is that it's a newly forming galaxy. And we're talking really early universe here, about 600 million years after the Big Bang.
Whoa, that's way back in time.
It is, and that's significant because that's around the same era when our very own Milky Way was just starting to come together.
So, wait, it's like we're looking at a baby picture of our galaxy.
You could say that, yeah. Except, of course, it's a different galaxy altogether.
Mind-blowing to see so far back. So, what else is so special about this Firefly Sparkle?
Well, what's really got astronomers buzzing is that Firefly Sparkle seems to have a mass that's very similar to what we believe the Milky Way had at that same early stage.
Hold on, so it's not just that we're peeking back in time, but we're looking at a galaxy that was maybe kind of like a twin to our own baby Milky Way.
Exactly.
That's incredible.
Right. And, James Webb Telescope has spotted other galaxies from this same early period, but those have all been much more massive.
So Firefly Sparkle is like the first one we found that really matches up with what we think the Milky Way was like back then.
It is. And that's why this discovery is such a big deal. Because, you see, it throws a bit of a wrench into what we thought we knew about how galaxies like our own formed.
Oh, really? So how does this, challenge the existing theories?
Well, the prevailing idea was that galaxies in the early universe were mostly these massive behemoths that formed through these, huge bursts of star formation.
Right.
But Firefly Sparkle, it seems to have grown much more gradually, and that might actually be more common than we originally thought.
So maybe the Milky Way, with its spiral arms and all its billions of stars, maybe it's not such a unique snowflake after all.
That's one of the really exciting possibilities that Firefly Sparkle is raising. It suggests that the Milky Way's formation process might not be an anomaly, but rather a more common path for galaxies in the early universe.
Wow, that's a pretty major shift in thinking. Okay, but how is it even possible to get these super detailed images of a galaxy that existed billions of years ago? I mean, it's like time travel.
It is incredible, isn't it? And the answer lies in the amazing power of the James Webb Space Telescope.
Oh, of course.
This telescope, with its advanced technology, especially its infrared capabilities, it can see through the dust and gas that would normally block our view of these faraway objects.
The James Webb Telescope, it really is like a time machine.
Indeed. And in the case of Firefly Sparkle, the images are so sharp, so detailed, that they reveal something really fascinating. We can actually see 10 distinct star clusters within the galaxy.
Okay, so I know our galaxy has star clusters, but is 10 a lot?
Well, it's not about the number itself, but what it tells us. You see, these clusters are like building blocks, and their presence suggests that Firefly Sparkle, just like our Milky Way, it grew over billions of years by slowly gathering these clusters together.
So it's like looking at the individual ingredients that eventually got baked into a cosmic cake.
A very delicious analogy. And it gives us this incredible glimpse into the very processes that were happening in the early universe. Processes that led to the formation of galaxies just like ours.
Whoa, hold on. I have a million questions now. How do these star clusters even form in the first place? And what about this gravitational lensing thing I keep hearing about? Does that have something to do with how we can see Firefly Sparkles so clearly?
Those are excellent questions. And yes, gravitational lensing is key to how we're able to see objects that are so incredibly far away.
Okay, then let's unpack those mysteries. Don't go anywhere. We're just getting started.
Before we dive into the nitty-gritty of, gravitational lensing and star cluster formation, can we just, take a moment
to appreciate how cool this is?
Exactly. I mean, we're studying a galaxy, Firefly Sparkle, that existed over 13 billion years ago.
It really is mind-boggling. Okay, back to my question. How do we actually see something that's so incredibly far away? It shouldn't even be possible, right?
Well, you're not wrong. With our usual ways of looking at space, it kind of is impossible. But that's where gravitational lensing comes in. Okay, imagine this. You're looking through a glass of water at something behind it.
Okay, got it.
Notice how the curved surface of the water, it kind of distorts the image, makes it look bigger, maybe a bit wobbly.
Yeah, I've seen that.
That's the basic idea. Gravitational lensing, it's kind of like that, but on a cosmic scale. So picture this. Between us and Firefly Sparkle, there's this massive cluster of galaxies.
Okay, there's a lot of stuff between us and this galaxy.
Right. And the gravity of this galaxy cluster is so strong, so powerful, it actually bends the light coming from Firefly Sparkle, like that glass of water we talked about.
Whoa, wait, so the gravity of that galaxy cluster is acting like a giant magnifying glass in space.
You got it. And it's that magnification that lets us see Firefly Sparkle with such incredible clarity. Without it, that galaxy would be way too faint, too distant, even for the James Webb Telescope.
So it's like the universe itself is giving us a helping hand to see further. That's pretty awesome. Okay, but hold on. How does gravity even bend light? I mean, light just seems like, it should just zip through space, right? Not get bent by gravity.
Yeah, it's a wild thought, isn't it? But Einstein's theory of general relativity, it tells us something amazing. Gravity. It's not just a force, it's actually like a curvature of space-time itself.
Space-time. Okay, you're going to have to break that down for me.
So picture space-time like this, like a fabric, right? And massive objects like these galaxy clusters, they warp this fabric. And because light travels through space-time, its path gets bent when it passes through these warped regions.
Oh, I think I get it. So it's not that light is being, pulled by gravity, but it's more like it's following a curved path because space itself is curved.
You nailed it. It's a bit mind-bending, but it's the reason we can see things that would otherwise be hidden from us. Gravitational lensing, it's like a natural telescope, amplifying the light from these faraway galaxies.
Okay, so that explains how we can even see Firefly Sparkle. Now let's go back to those star clusters. You said they're like building blocks of galaxies, right? How does that all work?
All right, so picture this. You start with these enormous clouds of gas and dust just floating around in space. Over time, gravity does its thing, pulling these clouds together.
Okay, so they start clumping together.
Right. And as these clumps get denser, they heat up. Eventually, they get so hot that nuclear fusion ignites at their cores. And boom, you've got a star.
So each of those star clusters in Firefly Sparkle, they're like little nurseries for baby stars.
That's a great way to put it. But it's not just about baby stars. These clusters, they've got stars of all ages at all different stages of their lives. Some are still forming, hidden in those clouds of gas and dust. Others, they've already lived long lives and are kind of, in their twilight years.
Wait, hold on. You're saying we can actually see different stages of a star's life all within the same galaxy? A galaxy that existed billions of years ago.
It is pretty amazing, and it's all thanks to the James Webb Telescope. Remember, it's infrared vision. That lets it peer through the gas and dust that blocks visible light. And since these clusters have stars at all these different stages, it's like getting a sneak peek at the entire process of how stars evolve, stretched out over billions of years.
That's just wild. Okay, so we've got these star clusters forming, each with its own collection of stars of different ages. How do they all eventually come together to create a whole galaxy?
Right.
Like Firefly Sparkle, or even our own Milky Way?
Now that's where things get really interesting. It's a cosmic dance of gravity, mergers, and galactic evolution, all playing out over vast stretches of time.
Sounds complicated.
It is. But basically, these star clusters, they're all interacting with each other, pulled together by their mutual gravity. Sometimes they collide, sometimes they merge, and this creates larger and more complex structures.
So, like a cosmic game of bumper cars, with these star clusters bouncing around and eventually clumping together to make a galaxy.
Haha, that's a fun way to think about it. Though it's important to remember these collisions, they happen over millions, even billions of years. It's a slow, gradual process, but the end result is something magnificent, like a spiral galaxy.
It really makes you appreciate the immense scale of things, doesn't it? All these forces and processes happening over billions of years just to create the universe we see today. And it's amazing that we can study a galaxy like Firefly Sparkle in such detail.
It's a testament to human ingenuity. I mean, think about the scientists and engineers who built the James Webb Space Telescope. Incredible.
This deep dive has been quite a journey. We've traveled through time and space, talked about how gravity can bend light, and even peeked into the stellar nurseries of a baby galaxy. But there's still one big question lingering. Does Firefly Sparkle tell us that our galaxy, the Milky Way, is more common than we once thought?
That's a question that astronomers are going to be pondering for years to come as they analyze all the data from Firefly Sparkle.
Well, I can't wait to hear what they discover. Stay tuned, because we're going to dive into the implications of this discovery and what it all means for our understanding of the universe. All right, welcome back. We're wrapping up our deep dive into Firefly Sparkle. And wow, what a journey it's been. From gravitational lensing to star clusters, this ancient galaxy has really challenged our understanding of the early universe.
It really has. Remember we were talking about how those other early galaxies we've observed, they've been much bigger, much more massive than Firefly Sparkle.
Yeah, those behemoths.
And that led to this idea that galaxies in those early times just grew super fast and violently.
Right, like some kind of cosmic explosion of stars.
Exactly. But Firefly Sparkle, it's kind of thrown a wrench in that thinking. Its mass is surprisingly similar to what we think the Milky Way was like way back then.
Much calmer, more peaceful growth.
Exactly.
So maybe those massive, rapidly forming galaxies, maybe they aren't the norm after all. Could it be that galaxies like Firefly Sparkle and, by extension our own Milky Way, are actually more typical?
It's a really exciting possibility, right?
Yeah.
And it forces us to rethink our models of galaxy formation. Maybe the Milky Way's story, this gradual buildup in evolution, is a more common path than we initially thought.
It's kind of humbling, isn't it? Our galaxy, with its spiral arms, its billions of stars, maybe it's not such a unique snowflake after all.
I know, and it opens up so many more questions. If Firefly Sparkle really is more representative of early galaxy formation, what does that tell us about, the evolution of the universe as a whole? How did these star clusters even form, and what determined if a galaxy went down this path of rapid growth or slower evolution?
So many questions. It's like every discovery leads to a whole new set of mysteries waiting to be solved.
That's what makes science so captivating, isn't it? Always pushing the boundaries, peeling back the layers to uncover even more wonder and complexity.
And speaking of wonder, one thing that's really struck me is how the James Webb Space Telescope has become almost like a character in this story. It's not just a tool. It's like a portal to a time and place we could never experience otherwise.
You're absolutely right. It's given us a new perspective on the universe, revealing details and objects that were hidden before. Who knows what other incredible discoveries await us?
It's almost overwhelming to think about. Every new image, every bit of data has the potential to reshape our understanding of the cosmos.
And it all starts with curiosity, that drive to explore, to ask questions, to push beyond the limits of what we know. That's what fuels science. And that's how we get discoveries like Firefly Sparkle.
This deep dive has definitely left me feeling small,
Yeah.
but also incredibly inspired.
Yeah.
Small when I think about the vastness of the universe, but inspired by the human capacity to explore and understand it.
I couldn't agree more. The universe is a tapestry of wonder and mystery. We're just starting to understand its intricate threads.
That's a beautiful way to put it. And as we wrap up our exploration of Firefly Sparkle, I hope you're left with that same sense of awe and curiosity. Keep looking up, keep asking questions, and keep exploring the wonders around us. Until next time.